Thanks for tuning in. Today it will be the most important and the most exciting video from the journey about the unified namespace from my point of view, because it brings up the topics that are not is not that covered over the internet, which is integration of transactional systems into the unified namespace. And is MQTT that good for that? So let's jump straight into it and figure it out. To start our journey about the MQTT within the unified namespace, let's strip out the most of the systems and focus on a couple of them. We'll talk about MES implementation and also about MES to ERP connection through the unified namespace. What you see here is basically MES, one connector in between, and unified namespace. Why I'll mention connector here is because from my experience, unfortunately, there is no connectors that natively connect to unified namespace. You always have to implement that yourself to the MES that you're working with. And for example, here I grabbed the Gartner report leaders in MES implementation. And yes, all of them report that they support MQTT, but you have to distinguish between the term support getting the data out of MQTT broker into the MES, and they all support that obviously, but exposing back the data, the business transactional data from MES system, I did not find any information about any kind of exposure of MQTT data back. I know that SAP is working on something that will expose data through the MQTT also. So looking forward to it, but so far I haven't found any evidences that one of those systems support natively the publishing MQTT events, like about the business information, like downtimes or some yield and production and so on, back to MQTT broker. Let me know in the comments if I'm wrong, if someone worked with either of the systems. I worked with some of those. And they do not support the MQTT so far. So let's discuss the idea one more time. The idea was a promise of unified namespace that we have the business system, in this case MES system, that somehow connected to unified namespace. Yes, we can retrieve data from the devices through the MQTT, but we cannot publish the data back about that is produced inside the MES. So the integration is unidirectional, not bidirectional. And to make it bidirectional, you basically need to implement the connector that either uses some kind of interfaces from the MES and publish the data out to the unified namespace. To continue, basically what we need to understand is what the basic flow inside interaction between the ERP and MES, so that we can in the end integrate those two systems. So there is a quick introduction into ERP terminology, let's say, that we need to go through that probably will be beneficial for you. So let's start with the first step. When we want to produce something, in this case, we produce fancy elephant chairs. And the guys who do the global planning, they plan, hey, we do fancy elephant. And what we need for that? We need basically to material cut, assembly, and package. Very oversimplified steps, obviously, but that defines 3 steps to produce the product. And they tell, hey, for each step, the process will take 10 seconds, for example, and then for that we need the specific materials to assembly from. So it's chair legs, 4 amount, and the seat base, 1 amount, and some screws that I forgot, bed planner. From the sales side, basically after we defined what we want to sell, the sales guys go in and start selling. They sold some 10 chairs to be produced by 23rd of October, and it goes into execution. In the execution, what you need to do is to create production order. Production order is created based off the production routine, which defines the steps and what materials to be used. They be used to create production order, and that basically multiplies 10 to define how amount of materials we need to use and which steps we need to do to accomplish the sales order. Operations are the steps that needs to be done to complete the order, at least the sequence of operations. During the execution, what you see here, some entities are created on the MES side. It's downtimes, so output, the tracking of the output, and then the end, the confirmation of that we submit some specific fancy elegant chairs back to ERP system so that we can track, yes, we produced fancy elegant chairs, so that it can go further down the line in other modules inside the ERP to track the shipping and other stuff. And that basically defines the exchange of entities between two systems that we want to do through the UNS in the end. So how technically we want to do it from the IT side of things? We have those entities, and basically what we need to end up with is synchronizing those entities, maybe except the sales order, everything related to production will be synchronized to MES. How to do it? Technically, you need to first face some interfaces. There are different types of interfaces depending on the system. Like, let's say modern ones are REST API and some kind of event buses, if you're lucky enough. Commonly, it falls back into some databases, and unfortunately, there is still a lot of SOAP services that needs to be exposed, like grab the data inside the ERP, and there is some module that exposes this data through some SOAP endpoint that you need to connect to, for example. Worst case scenario, you just need to directly go to the database and query the data, let's say raw data out of the database from the system that you want to use. And after you extracted it out, so there is a process to connect to it, extract it out, you put it, let's say, in the same format that you extract it out, or this system is responsible to put this data inside this storage. And the extract is within the boundaries of the ERP. As you see, it's blue still. Then you have the transformation process that transforms it to be more or less universal across the different ERP systems and MES systems. So it defines this universal structure that you define within the organization to track the entities. And then there is load process that transforms it from this universal into the customized to MES structure format, and there is a specific process that loads this data. So in a nutshell, you have 3 processors and 2 storages to store the data during this process. And then the same basically happens back when you want to synchronize the data out. So it's extracts and stores in the, let's say, green. Then you have the transformation mechanism to store it in UNS one, and then you have the load process to load it back. And that basically defines the interaction between those two systems. And how it helps during the scaling. You have the direction of data you see here from ERP into MES, and you have this shared UNS that's shared across different plants. And for example, you have different ERP with different interfaces. Those extraction and storage needs to be implemented to store this stuff. Then you need to implement this transform mechanism to transform from different format into UNS. And then you need to load it to another MES system. And then if you are lucky enough, on plant 3, you have basically, for example, the mix from the first plant that you use the same ERP, and the plant is using the same MES as plant 2. Then you will be lucky that you can reuse both of extraction and load mechanisms, and that will save you the cost of scaling this implementation into other plants. If the systems will be different, you will have to implement different extract and load mechanisms per plant. And with that said, let's assume that we want to use MQTT, and let's challenge a bit the MQTT protocol here. If you want to have the transactional data flowing through the system, you want to be absolutely sure that you do not lose data. And in good scenario, yes, you can process each data, everything is fine, but a negative scenario where your processor hung, there is some memory issue, there is something goes wrong in the processor, whether your UNS needs to sustain this failure. So you need to restart the process, and the process will start at the place where it left. So it needs to have some kind of watermark in terms of processing. Also, it should support batch processing, because if you think about the previous example with the material and ERP integration, the events can be considered downtime is a good example of event. But if you think about the production order, which has multiple components inside, like material, usage, and other stuff, all of that is changing, like the underlying entities are changing. And if you will be emitting the signal on each change of this small entity, there will be like huge overhead of the data that you need to pass through to pass this data. That's solved a lot of times if you just standard ETL tools that you want to extract the data by batches and then synchronize it to another system and transform this data to the format that this system wants. As line of business integration systems are commonly like this Snowflake, Databricks, or other data processing systems, this UNS protocol-wise needs to be well integrated with the cloud tools. Also, it should support stream processing, ideally, and also it needs to subscribe to events on different level of the hierarchy. So let's just quickly go through what MQTT supports. We know from previous video and that it does not support the history. The queuing mechanism inside the MQTT is not sufficient enough to handle the issues during the processing of the data. If nothing is subscribed, you cannot just return back and grab the previous data out. If you consumed the message, you processed it, then it's gone. Yes, if you failed the processing, you can return the message back. It will be handled back to the broker will send it back, but it's not as reliable when you face some issue, I don't know, like 12 hours later, you need to process data for 12 hours. MQTT is not good for just watermarking the stuff. Was not made for ETLs to run on top. It does not support batch processing due to the nature. It's not as well integrated. Yes, there are libraries like in Databricks. There is a Python libraries to work with MQTT, but it's not native to the tools that the ETL tools are using. And it was made for stream processing, and you can subscribe to hierarchy level events if you need that. From that point of view, MQTT shines. If you'll grab another technology called datalake of some kind, right? It's like standard, basically the storage, right? That stores the messages. It obviously supports the history, right? Datalake is just the storage that has the files, commonly in Parquet format, that's saved to be consumed by some ETL processing tools. In this case, history is preserved. You can return back, you can reprocess whatever you want, so you're safe from that point of view. Also, it supports batch processing, again, due to the same reason. You just saves the file, you can group that, and it's actually preferred way to do it like that. So you need Parquet files, needs to be of certain size so that it can be efficiently processed by the engines, and you'll just do batch processing of the data. Is it well integrated with ETL tools? Absolutely, right? Because like data lake is primary storage for all the ETL based tools nowadays. Regarding the stream processing, data lake is not the stream thing, it's more of a batch processing thing. That's why it does not support that if you need that. And hierarchy level events, I put the question mark here because it does not support it, but also ETL tool at this point does not care, because it can query the data efficiently without the knowing of the data, query the data granularly without overhead, because it can be partitioned so well so that the query will be very fast. And if we want to sum up and put this layer on top of our architecture, so what you see here from previous video is that it's our implementation using unified namespace, our SCADA, protocol translator, so PLCs. Some PLCs report MQTT directly, some PLCs go through protocol translator that exposes MQTT, like it transforms them to MQTT. And then there is a SCADA, for example, that works with MQTT natively. Probably more than SCADA does. I only faced actually old ones, unfortunately. And then the IoT platform, the data goes out using, again, MQTT to some UNS IoT platform connector that converts this data, it batches this data, and it converts it to Parquet format, which is native to ETL tools that want to process that. And that saves basically two unified namespace data lake. So what is funny here is that we end up with two unified namespaces, right? One with the stream processing capabilities on the shop floor. But if we're talking about transactional data integration, the transactional data integration will happen only through the unified namespace data lake. And MES system, it can consume the data out of the devices, but the integration of the business systems will happen through the data lake. And it will use Parquet as a data exchange mechanism, and it will use some kind of APIs, like I mentioned previously, different types, to exchange the data out. But it will not use the MQTT and unified namespace, from my point of view, as an exchange mechanism, and MQTT broker as a central place to store the data. And that's the thing that I wanted to point out, and that's why I've created this set of videos to provide my point of view into the unified namespace. And I think it's significantly overlooked at this point of time in the community that everyone tried to build MQTT-based unified namespace that handles all scenarios. And I think it's not an occasion that all business systems still do not implement MQTT as a data exchange mechanism for transactional data, because the protocol was not made to handle this scenario. And there is much better way to handle the transactional data than using the MQTT. So hopefully that helps. I really appreciate the comments on this topic. I think it's not significantly covered in the posts videos that I saw, at least. Let me know in the comments if there are some examples of implementation of that. We implemented some of those, and we actually, why I'm bringing this up, because we faced the problems with MQTT and we know that the problem exists. And we also implemented the ETL processes on top of the data lake that work much better. So I have example myself. I hope I can cover it in the future videos in more details. But I'm hoping to get the feedback from your side. Thank you very much.